Well, we have another question here. The question says that given f of x equal to negative ax squared plus bx plus 6, and then question 4.1 says that's the gradients of the tangents of the graph, the gradients of the tangent to the graph of f at the points negative 1, 7 over 2 is 3. Show that a equal to a half and b equal to 2. Now, I'm going to start by writing the question over here. Excuse me. Question 4. Excuse me. Question 4 is given that f of x equal to negative ax squared plus bx plus 6, and then 4.1. We want to find the value to prove that a equal to a half and that b equal to 2. Okay. So what can we do? All right. First of all, we need to understand the meaning of the words here and how we can represent them, okay, in equation, mathematical equation. When they say the gradients of the tangent line, you need to know that the gradient of a function is given by, I say m. It's the gradient of the function is given by the derivative of that function. Okay, that's the gradient of the function. So we need to prove that the gradient of this function is equal to 3. How can you do that? First of all, let's find the derivative of the function. So because we have f of x, okay, equal to negative ax to the power of 2, okay, plus bx plus 6. Okay, the derivative of this function f prime of x will be negative there. It's going to be 2 times a times x to the power of 2 minus 1. Okay, plus what? 1 times b times x to the power of 1 minus 1 plus 0. Why am I saying that? Just because the derivative of a x to the power of n, okay, this is just equal to n times a times x to the power of n minus 1. So first, the exponent get down, okay, and then we have like n times a times x to the power of n minus 1. So, and then over here, when you don't see any exponents, okay, first of all, over here, negative a x to the power of 2, n is like 2, okay, and then a is the coefficients. Obviously, a is the coefficient of x squared. So now the n get down, okay, 2. The negative sign was there, negative 2 times a times x to the power of 2 minus 1, okay, and then over here you need to understand if you don't see any exponents on the x, understand that it's just 1. So that's why I say 1 following this formula, okay. We have 1 times b times x to the power of 1 minus 1. And then the derivative of all constants, meaning numbers like negative 3, like 17, like 3 billions, the derivative of function is just equal to 0. Okay, so this is 0. Then I can write it like, let me simplify. Before I do, they say that the gradients, they consider the gradient of the tangents, so the derivative of this function is equal to 3. So I'm going to sub in the value of 3 for f of x, start the derivative of the function. So 3 will be equal to negative 2ax, okay? And then it's going to be like plus 1 times b just b, and then x to the power of 0 is just equal to x. So it's going to be that 3 equal to negative 2a plus b. Now this, and then it is also said that it is the gradient of the graph at the point negative 1, 7. So you know that the coordinates of the points are like x and y, okay? So meaning because it's the tangent passes through this point in the graph, we can sub in the value of x by negative 1, okay, and then with the value of y 7 over 2. Now, first of all, at the point, because it is gradient at that point, -1, it means I can sub in the value of x -1. So it's going to be like 3 equal to -2a times x plus b. So I'm going to say here at the point -1, 7/2. So I sub in -1 there for x, and then this will be equal to 3 equal to 2a, because 2a times -2a times -1 makes positive 2a plus b. Okay, we can call this like equation 1. Now, the same point here, the point here is where the tangent passes, is a point on f. So I can substitute the coordinates of this point in f here. This will be, because f of x is given by -ax² plus bx plus 6. If I sub in the points, the point is going to be like f of x. Okay, let me write f of x is -ax² plus bx plus 6. I want to sub in the points, the coordinates of the point. So f of x is something as the y value, so it's going to be 7/2 will be equal to negative. I'm going to sub in the value of x. Okay, so 7/2 equal to -a times x to the power of 2 plus b, open bracket like that, close bracket, and then plus 6. Now this will be, let me write it over here. This will be 7/2 equal to, over here we first work out what is in the bracket. Okay, please don't say -a times -1. No, because there's a bracket here. There are some priority here, order of priority. So we do -1 to the power of 2 is 1. -a times 1 is -a. So that makes -a. And then b times -1 makes -b. Okay, and then plus 6. Now I want to solve this. What I can do, I don't want to work with fractions. Okay, so I want to get rid of these two. I will by timesing the whole equation by 2. So I want to times here by 2, I times here by 2, and then times all this by 2 also, and then this will become this will become 7 equal to -2a -2b plus 12. Okay, so if I move the 12 over, okay, this is going to be, or maybe I can just I just want to move -2a and -2b over. So that will be positive 2a, because I've moved -2a on the other side of on the left hand side of the equation. And then so also I also move -2b on the left hand side, so we 2b equal to 12, and if I move 7 on to the right hand side, so you minus 7, and this will be equal to like 2a plus 2b equal to 5. Okay, this is like equation 2. But now see how my equation 1 was written. I wanna do the same also with this, so I can just reverse the order. So this is the same as saying like 5 equal to 2a plus 2b. Now this is equation 2. Then I can then combine the two equations because they have same variables. Okay, so let me I want to write, I can do equation, let's just keep equation 1, let's just say equation 2 minus equation 1. So this is what I want to do. Equation 2 minus equation 1, this will be like 5 equal to 2a plus 2b. Okay, oops, sorry about that. Just my tablet. 5a plus 2b, 5 equal to 2a plus 2b, and then 3 equal to 2a plus b. So if I do, as I said, equation 2 minus equation 1, I'm going to have 5 minus 3. This is equal to 2, and then 2a minus 2a is 0. So this will cancel out because they make 0. And then 2b minus b is just b. So we have like b equal to 2. This is proven. Okay, remember, we mainly, the question was, we wanted to prove that B equal to 2 and then A equal to a half. Now, we got B. We can substitute the value of B into either equation 1 or equation 2. Okay, remember, this was equation number 1, and that was equation 2. So I want to sub in either, in any of these equations. I prefer to sub in equation 1. So this would be like 3 equal to 2a plus b. I sub in the value of b, which, okay. And then if I move 2 over, that makes 3 minus 2 equal to 2a. And then 3 minus 2 is just -1 equal to, actually, not -1, but 1. 1, and then equal to 2a. And if I need to find a, I will divide both sides by 2, and then we'll have a half equal to a. Therefore, a equal to a half. So that was the value. Those were the value of a and b. And then I'm gonna move this on the other side. I'm right here equation question mark 4.2. What the question says, let's move question 4.2. Voilà. 4.2 says calculate the x and the x-intercepts of f. Now, now that we know the values of a and b, we can substitute, because here we're looking for the x-intercept. Excuse me, looking for the x-int. Let's write it like this. X-int. Okay. Now, x-int is calculated if y equals to 0. It's when we make y equal to 0. F of x was given by -a x squared plus bx plus 6. Okay. Now that we find the value of a and b, we can substitute. F of x will be equal to -a squared plus bx plus 6. We sub in the value of a, which is a half, and then b is 2. So x-intercept means, as I said, we make y equal to 0. Okay, f of x is the same thing as y. So instead of writing f of x here, I can just write y. Okay, that's it's y over here. Now we're going to make y equal to 0. So we're going to substitute this equal to 0 equal to -1/2 x squared. I don't need brackets here. -1/2 x squared plus 2x plus 6. So if I need to find the value of x, we can start by timesing the whole equation here by 2, because I don't want to work with fractions. Okay, I times here by 2, and then I know that 2 times 0 is 0. And why I times by 2? Maybe because I want to get rid of this fraction. Okay, so I times everything by 2, and then 2 times 0, we know it's 0, equal to 2 times -1/2. That makes -x squared, and then 2 times 2x makes 4x, and then 2 times 12 times 6 makes 12. Now, if I move them on the left hand side of the equation, that makes +x squared minus 4x minus 12 equal to 0. Now we can solve for x. I put x in the bracket like that, and x also in the bracket, close bracket equal to 0. Now I'm going to consider the constant term -12. Over here I'm going to write -12, and then the factors of 12 are like 1 and 12, 2 and 6, 3 and 4. Okay, now I want to ask myself this question: what couple in the list of the factors of 12 will make a a sum equal to -4. Okay, so I'm gonna look at the couples. You know, with 1 and 12 we cannot make -4. With 3 and 4 we cannot make -4, but with 2 and 6, yes, we can, if you have like a +2 and a -6. So I'm gonna place in here +2 and there -6. Then what does this mean? It means that we do x +2 equal to 0, or x -6 equal to 0. So if I move the 2 over, that makes x is equal to -2, okay, or x equal to 6. So this would be the value, the x-intercept. So that's question 4.2. And then let's see, the following question is must be question 4.3. Just gonna move it here on my board. Oops. Question 4.3. The question says, calculate the coordinates of the turning points of F. All right. Already, because f of x is given by, let me move this over here. Question 4.3 right here. So we're looking for the coordinate of the turning points for xTP and yTP. The turning points of f of x, actually, which is given by negative. We did calculate it in the previous video. In the previous question, a was a half x squared plus b was 2, and then x plus 6. Now, there are different ways to solve the turning points. I can use the quadratic formula, x equal to -b over 2a. Okay. Over here, I will substitute the values of a and b. So it's gonna be like b here is +2, and then b is -1/2. So if we do, you can notice already that the negative sign here, negative sign will cancel out, and then we have like 2 divided by 1/2. This is equal to 4. Okay. Actually, 2a, I missed to write 2a. Sorry. A is 1/2. Let's just erase this. Yeah, a is 2 a 2 times 1/2. So that will make 2 over 1, which is just 2. Okay, x is equal to 2. Now that we find the value of x, we can substitute its value in the function itself. So we're going to work out f of 2, knowing that f of 2 is the y value. So -1/2 times x squared plus 2x plus 6. So I sub in the value of x, which is 2. And then when I sub that in the calculator, this will be 2 squared is 4. -1/2 times 4 will be, so it's gonna be like -1/2 times 4 plus 4 plus 6. And then that will make -1/2 times 4 is just 2. 2 plus 4, excuse me, -1/2 times 4 is -2, and -2 plus 4 is +2 plus 6 is going to be 6. So remember, y of 2, f of 2 is just y. So now we got, therefore the turning points is just the points 2. I say 6, I meant 8. 2, 8. 2, and then 8 here. That's the turning point. Or another way to solve the turning point is, especially when we find the intercepts, okay? You can just find the averages of the intercepts, like x-TP will be x1 plus x2 over 2. Now this will be x-TP will be equal to, we did find the intercepts over here. They were -2 and 6. So I am going to do -2 plus 6 over 2, and -2 plus 6 is +4 over 2. That makes x-TP equal to 2. Now that we find x is equal to 2, we will substitute its value 2 in the function here, and then we'll get y equal to 8. So the turning point is the points to 8. Next question must be question 4.4. Let's move over here like that. Must be the question 4.4. The question says, sketch the graph of f, okay, clearly indicates all intercepts with the axis and the turning points. All right, let's move the board like this. I'm going to, let's split it. I'm gonna split it here like that. So question 4.4. So over here, the question says that sketch the graph of f, excuse me, and clearly indicates all intercepts with the axis and the turning points. All right, f of x is given by now -1/2 x squared plus 2x plus 6. Okay. Now the intercept, we find the intercept where x-int, where we did find in the previous videos, there were -2 and 6. Okay, in the not previous video, but in the previous question, remember we did find -2 and 6. Those are the intercepts, the x-intercept, and then the axis of symmetry is also just the x value of the turning point. Okay, axis of symmetry will be axis of symmetry will be x is equal to, is the x turning point. Okay, x is equal to 2. And what else? Okay, we don't have the y-intercepts, so let's find the y-intercept. So y-intercept means implies that x equal to 0. So this will be y will be equal to -1/2. Actually, I don't really need to do that, because the constant term will always be the y-intercept. So this is basically something like we sub in the value of x0, and then we get like y equal to 6. So I'm going to write over here that y equal to 6. So let's draw the graph. So I'm gonna draw my graph over here. Just give me a second. Trying to adjust my ruler so I can just make it. I can make it over here. So this would be y-axis, and then the x-axis. I draw the x-axis. Okay, that's y, and then the x goes like that, and then goes down also for it. Now, the fact that my parabola, I call it parabola because this is a quadratic equation, okay? Because the graph of quadratic equations are parabolas. Now, I need some parameters, some information from that. I know that the parabola can have either a U-shape or an inverted U-shape. It depends on the value of A, the leading coefficients. If A is positive, then it has a U-shape, sometimes called a smiley face. And then if A is negative, less than 0, then it has an inverted U-shape called sad face. So in this situation, I already know that my parabola must be an inverted U-shape. Okay, so it's this one. That's the first thing, and then let me place in the critical point. I'm referring to the intercept. It was -2. So if my, let's say one is over here, one is here, -2 will be there, so -2 is there, and then the other one was 6. So 1, 2, 3, 4, 5, 6. Okay, I cannot be accurate, but I will try to be accurate one drawing the graph, because I know we're gonna use free hands, but my graph cannot look like this, for instance. Okay, so it must be at curves. They cannot be straight lines. And then the y-intercept is 6. So let's say 1, 2, 3, 4, 5, and then 6. Let's say 6 is somewhere there, and then y-intercept is here, and then my turning point is by 2, 8. So if 6 is there, 8 must be somewhere there. Then we can draw the graph. So now, try not to make straight lines, but make curve. Okay, when drawing this graph. Okay. What am I doing here? It wasn't really there. But the point is over. It's somewhere there. Let me move this a little bit up there. I'll move it closer to. Yes. I don't want it to. Good. So now I can draw my graph now. I'll try not to make it a straight line, but the curve here, that's the deepest point. So it's gonna be something like that. Passes through something like that, and then it also goes like this. So the parabola must look something like that. That's my parabola. And then also the line of symmetry, you know, the line of symmetry here must be a vertical line. It's the line that passes through the turning point. So it must be through the x value of the turning point, which is the x value of the turning point was 2. So it's the line that's this dashed line here at the turning point. Okay. Yeah. So this dashed line. Good. Okay, and now we have another question here, question 4.5, the following question. What does it say? Question 4.5, the question says that use the graph to determine the value of x for which f of x is greater than 6. Okay. I'm gonna move my board over here. So we have like question 4.5. They say that f of x is greater than 6. Now remember that we did find that f of x was equal to negative r half x squared plus 2x plus 6. Now they say this will be greater than 6. Now we're looking for the values of x, okay, for which f of x is greater than 6. It means that if I move 6 over, that will be f of x will be negative a half x squared plus 2x greater than 0. Now from here, we will understand that the graph passes through the origin because it's like plus 0. Let me just say plus 0 here, because 6 minus 6, I'll show you like this. Plus 6 minus 6 is greater than 0. And then this will be negative a half x squared plus 2x plus 0 is greater than 0. Now, passing through plus 0 here, I did it on paper just to show that this graph will pass through the origin, because we have like the y-intercept here is 0. This same graph, let me just move and then show you. This graph here will actually shift like 2 units to let's see. Okay, or maybe I just want to I know the shift will be like, but I don't want to really talk about the shift here. But first of all, I prefer to do this. Okay, it means 0 over there. Meaning if I take x, let's do this way. Is greater than 0. Now, if I take x as a common factor, okay, to find the critical values, like I'll take x as a common factor. It's going to be like x, open bracket, close bracket there. That's going to be negative a half x plus 2 greater than 0. Now, this means that either x is equal to 0, the critical values, or negative a half x plus 2 equals 0. I'm talking about the critical value, so I'm going to set the inequality equal to 0. Now, if I move the 2 over, we have like negative a half x plus 2, actually, equal to negative 2. If I times by 2, or by negative 2, this is going to be like x will be equal to 4. Okay, if I times here by 2, and then they also by actually negative 2 and negative 2, x is equal to 4. So now the critical values here are x is equal to 0 and x is equal to 4. Now we know that f of x is an inverted U shape. So meaning one of the intercepts is 0 and the other intercept is 4. So therefore, the function will be greater than 6 if x is greater than 0, okay, or x is lesser than 4. So we can write this like this: 0 is lesser than x and x lesser than 4. So this is the interval we're looking for, the values of x for which f of x will be greater than 6. Thank you. And then the following question is, I'm gonna move here. Question 4.6. Question says that sketch the graph of g of x, which is given by negative x minus x on the same set of axes as f, clearly indicates all intercept and with axis. All right, we have another line here, g of x given by negative x minus 1. So on the same set of axes as f of x. Okay, so I prefer to move it to write it here. 4.5 g of x given by negative x minus 1. So we already know that the negative 1 here is the y-intercept. Okay, so this will be the y-intercept just negative 1, and then we can find the x-intercept if we set, okay, we say like x-int means make y equal to 0. So this will be 0 equal to negative x minus 1. If I move negative 1 over, okay, we have like, or if I move negative x over, we have like x will be equal to negative 1. So we have like negative 1 and 1. Negative 1 for the y-intercept and 1 for the x-intercept. No, negative 1 the y-intercept and negative 1 the x-intercept also. Now on the same set of axes, you can just we have like one intercept here by negative 1. Change the color, negative 1 over here on the y and negative 1 also on the x. So the line will pass through these 2 points, this one and that one. So I can just use my ruler to draw the line of the equation of g of x. Not exactly. Okay. Voilà. Et voilà, that's g of x. That's g of x. Now, let's see. The following question says is question 4.7. 4.7 says write down the value of x for which f of x times g of x is lesser than or equal to 0. Now, we can just do that over here. 4.7. So we're looking for the values of x, the value or values of x, okay, for which f of x times g of x is lesser than or equal to 0. Now, if I do f of x is so if this is less than or equal to 0, it means that f of x, okay, we need to find the critical values, okay? Critical values first. Critical values. So f of x we had like, it's like negative a half x squared plus 2x plus 6 equal to 0. Okay, and then I prefer to times the whole equation by 2, and then this will be, if I times here by 2 to get rid of the fraction, okay, I times there also by 2, and then this will be negative x squared. That should be negative x squared plus 4x plus 12 equal to 0. Now, if I times also, okay, if I can take, instead of timesing by 2, I prefer to times by negative 2, I meant. So this would be x squared minus 4 and then minus 12. So minus 4x and then minus 12. Now we can solve this by factorization. Okay, I want to take here, if I take the values of the constant term is negative 12. So the factors of 12 are, I think I did this one in one of the question earlier, 1 and 12, 2 and 6, 4, 3 and 4. So we can only select, to get negative 4, I'm going to take positive 2 and minus 6. So plus 2 here and then minus 6. So excuse me. Okay, now maybe we shouldn't do the calculation. We can just use the graph to do that. Okay, let's just use the graph, or the graph is over here. Check this out. Yeah, now we can see this. The orange graph is the g of x, and then the green is the f of x. Now the two, like over here, in this part, for instance, this part, g of x is more than f of x. F of x is negative and g of x is positive, because over here it's decreasing. Okay, so now the product here will be less than -2. I will say here the solution will be over here will be when x is lesser than or equal to -2. Okay, because here positive times negative makes negative, and also over here negative times positive, you see here it's decreasing, it's less than 0, and that side is more than 0 in this interval here. Between -2 and -6 here is less than 0. So I say x is less than -2, or x is in between -1 and 6. Okay, if you look at the graph carefully, let me go over it again. This part, g of x is more than 0, it's positive, and f of x is negative. Positive times negative makes negative. Negative is less than or equal to 0. Yeah. Now on the other side, you see here it's above the y-axis. Okay, g of x is f of x is above the x-axis between -2 and +6. And now g of x is below the x-axis only between -1 and 6. So we're just going to take the intersection where they make negative this part both all together. So between -1 and 6. So this is the solution. Or else you can do the calculation over here. Where is it? We can do the calculation here. You get x. The critical values will be -2 or 6 here. Okay, and then also you can work out x minus 1 equal to 0. The critical values will be x will be equal to -1, and then you could draw the number line here. You draw the number line, and then it represents all the critical values. Okay, maybe you can just try to be accurate a little. Yeah, accurate. Just gonna use my calculator to draw the number line. And then place in a number line my critical values. Okay, we have a -2. I place in the -2, -1, and then 6. And then you see if x is a number like a value like over here, a value like -3, for instance, you sub in -3 there for x, -3 for x, and -3 there for x. Now check this out. If x is -3, this part will be negative times negative, you make positive. Okay. Now this side also, minus will make +3, it's going to be positive. All this side. So meaning, excuse me, meaning, oh yeah, I almost forgot. We substitute here because here it's like there were a -2 there. Yes, so it's gonna be like this -2 times negative times negative, negative makes negative. So all this side is the solution. This side here is negative. So if you take also from -2 to -1, if you sub in -2 for x okay? Sub in -2 for x, then because I think here it's with this -2 times that, so factorize is going to give this. If you sub -2 for x, negative there, not -2, but a number between -2 and -1. Let's say -1.5. Pick up a number like -1.5. 1.5 here. If you sub -1.5 there, you're going to get a positive answer. You get this side is going to be positive. And then this side, if you pick up any number like 0, for instance, 0, you sub 0 over here. There you have like positive times negative times. This will be again another negative here. Negative. So because it's going to be positive times negative times positive times negative makes positive times negative here, it's going to be negative again. So the solution is actually x is lesser than equal to -2, or x is between -1 lesser than, okay, between -1 and 6. I have the impression to go over it a little bit. Over here, if you take a number like -3, you sub -3 for x there, you'll get like negative times negative times negative, it makes negative. If you sub -3 over here, it's going to be negative again. So it's going to be actually positive. So negative times positive makes negative. So this interval be lesser than -2 is going to be negative. If you pick up a number like -1.5, you sub there for x here, you x there. So 1, 2, 3. You check the signs. So negative times positive times negative times positive again, it will make positive. And then here also the same way, -2 times, if you sub a point like 0 for x, 0 for x there, 0 there, let's do it. If we sub 0 for x here, 0 for x there, and then 0 for x here, you have like, it's going to be negative number times positive, it makes negative, times negative again makes positive, and times negative here will make negative. So in this interval less than -2 and between -1 and 6, the solution is negative. Thank you. Just remember, you don't have to do it as I did here, or as it is done here in the graph. Okay, you can just select, because you can just answer it by looking at the graph. Like over here, you see all together here, positive and negative makes negative. So this is part of the solution. And then here also in this interval, okay, f of x is positive, and then g of x is negative. Positive times negative makes negative. So the solution in between -1 and 6, or lesser than -2. Thank you.